Click for IB Biology. Here we're looking at application of enzyme theory and the action of penicillin, the antibiotic. This is actually an example of irreversible inhibition. There's a PDF of this presentation in the description below, along with a quiz for you to test your understandings. So we're all probably very familiar with taking antibiotics where we have bacterial infections, as an example, and this structure here represents the wall of a bacterial cell. What happens with penicillin, so the drug is here, is that it will enter the active site of this enzyme and block it with irreversible inhibition. It will not, so in other words, it doesn't come back out so the enzyme can function again. It's a permanent feature. The enzyme in question is responsible for creating cross-links in the peptidoglycans of bacterial cell wall. So if we have our bacterial cell like so, and we know that when we draw such a structure, we often draw the wall going around the outside. So the peptidoglycans are the molecules that compose this wall, and it's necessary for them, the fibers of those, to be linked together, which is the action of this enzyme here. But what penicillin does is it stops this enzyme, so the links cannot be made and the wall becomes very permeable. The bacterial cells often lyse due to absorption of water and overexpansion of the cell. Penicillin resistance often comes about either through a mutation to the enzymes so that the penicillin doesn't actually bind into the active site anymore, or it could be that the bacterial cell produces enzymes which break down penicillin. So different modes of penicillin resistance.